the other one. Let's go to the second one. See, now it won't let me do it again. I don't know. Have I a mouse? Oh, there she is. Oy vey. Okay, let's clear this out. We're going to do kind of a simple one this time so you can see how this works. Now if I wanted to do top minus bottom, I realize I could negate it and put it in and do it the way we just did it for the second one, but I'm not going to do that. I'm going to kind of start practicing doing the other ones. So my top curve is 0, so let's do that. And let's come down to I2 and put in the bottom curve, which was x squared over 3 minus 4. Okay, and then second quit out of there. And math 9 again. And my limits of integration. Oopsie. Okay, right there you can put in top minus bottom. In other words, y1, which was our top, minus y2, which was our bottom. Thought that might, yep, I knew it was that. I don't know how to get rid of that. Oh, there, easy enough. And let's see, 145 divided by 9. Yep, we're good. Can everybody get that to work? See why we're doing y1 minus y2? Okay, so, all right. Let's go back over here and go to the next page here and do this one. This one's a cubic, and we're lucky enough to have the graph. We didn't have to do the graph ourselves. And we'll go ahead. We're not going to do this one by hand. We'll set it up, and then we'll just do it via the calculator. We have two pieces here. And we're going to actually have to do two separate integrals. Reason being, the top for one is different than the top for the other. Okay, bottom for one is different than the bottom for the other. So I'm going to start here on the left, and I'm going to set up an integral from -1 to 1. -1 to 1. Of x cubed minus 3x squared plus x plus 3. And I want to add to that. Oh yeah. Thank you. There. And we could put a -0 on the end because that's the bottom. I didn't. Over here though, from 1 to 2, what are we going to have to do? Yeah, do 0 minus all this stuff. Oh, I didn't think it was going to let me write on that, but it did. Okay, everybody good? Everybody see why we set it up that way? Let's put it on the calculator. Okay. Okay, for y equals, you can put 0 in for one of them if you want to. It's up to you. I'm going to leave that 0 right where I have it. I'm going to change my bottom one to the cubic. Okay, and if yours are different than mine, if your 0 is in a different place, then what you plug in next will be different as well. Okay, is everybody plugged in? Okay, let's do a second quit. I guess this works just as well as the mouse. Math 9. On this first one, we're going -1 to 1. And this one, if you want to do the -0, you can or not. I have my equation, or my top, in y2, so I'm going to do y2 this time. And if you want to do minus y1 here, if that's where your 0 is, that's fine. If you don't have to. Okay, so that's the first piece. Now I have to add on to that the second piece. So I'm going to math 9 again. Bring that up again, this time from 1 to 2. Okay, this time I will do y1 because it's 0 minus y2. How'd we do? Am I really, really slow? That I'm really, really slow? Any questions? So for many questions on the AP, you'll only have to set up the integral and then give the answer. You won't have to do any sort of work to do it. Let me go back here. So for this one, if that were the case, I could just say, okay, done. Like that. Okay, I think we're ready to go to problems like this, where there are actually two different curves. Okay, here we have one. Okay, we have a parabola that's upside down, and we have a chordic, which is like a parabola with a flat bottom. Okay, yep, turn the page. Turn the page. Okay, let me go over here. This guy really is up like that, in case you were wondering. Okay, so I need to find this area, and in some instances you'll have to know how to graph it by yourself. If you had to figure out how to graph this, well, I think we can all graph x to the 4th. I'm pretty sure. If you had to graph the parabola, I think probably all you'd really need to know would be the roots. So let me come over here. I would probably just do this. And then I would know that I have a root at 0 and a root at 2, because that's what makes these two pieces 0. Does that make sense to everybody? Yeah? Okay. Alright, so that would give us a picture. Even if you have a picture, there are times where you'll have to find the points of intersection, because you're going to have to know like where your integration begins and where it ends. Now here we're lucky enough to have a picture, but you usually won't be. So you'd have to know how to do that yourself, which you probably all do, but let's do it anyhow. Let's set this x to the fourth equal to the parabola. And solve. Let's get everybody on one side. Plus x squared minus 2x is 0. Okay, the first thing you would do here, right, is factor an x out. There's some craziness next door. Okay, this piece here would tell me that definitely gonna touch each other or intersect at an x value of 0, 0 something. In this case, if you look up here, you can see that it's 0. Or you can just, in your head, plug the x value of 0 in here. That gives you the origin. That's one point. This guy's a whole other affair. Okay? I think I'm going to try to scooch him over here. This would require a little synthetic division action. But first, you'd have to come up with a root. So in other words, you'd have to come up on your own with something that would make this 0. Let's pick 1. What a good idea. 1 works. So let's do a little baby synthetic division here with 1. Okay. Now I'm going to list the coefficients of all these. Don't forget there's an x squared in there, folks. So I got to use the 1x cubed, 0x squared, 1x, and negative 2. This one's just coming down. Okay, you ready? 1 times the root, 1. Add up 0 and 1. 1 times the root, 1. Add up 1 and 1. And finally, 2 times the root, 2. We were hoping for a remainder of 0, and we got it. Okay, so to continue factoring over here, we'd have x minus 1. Where the heck did that come from? Right here. Right? I love this part. I couldn't do that before. Okay, and then the second part's going to come from the 1, 1, and the 2, right? Decrease the power by 1, so that's 1x squared plus 1x plus 2. Okay, this will give me another point of intersection. I know they'll touch at 1 something. Well, the something's really easy to find. You can plug the 1 in your head right into this, can't you? That's your 1, 1 up here. 1, 1. Okay, you may be asking, well, what the heck do you do with this thing? I'm not going to do anything with it. I'm just going to tell you that if you Q it, right, you'll get imaginary answers. So it does nothing for this picture. I don't want to waste too much time on it. But if you did plug it into Q, you would have imaginaries. Okay, so far that's just finding intersection points. No calculus so far. Anybody have a question so far? All right, carry on. You know what? I want to come over here and erase this just so it's out of my way. Okay, we have to integrate this. We have to do a top minus bottom. The good news is I now know my intersection points, so I know I'm going to start over here at 0 and integrate all the way over here to 1, because that's where my shaded area is. Now I'm going to do top minus bottom. Top minus bottom.